Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we're going to summarize some of the top stories in science. Well, the lead story, of course, at least for the next several months, is the face-off between Hillary Clinton and Donald Trump. And if you look at the polls, the number one issue, even in spite of the fact that we had that notorious plane crash off the coast of Egypt recently, the number one issue is the economy, not terrorism. And then the question is, well, how bad really is the economy? Well, there are two figures that came out recently which are quite revealing. The first figure came from the Pew Research Organization, and it analyzed the demographics of young adults between the ages of 18 and 34 who still live with mommy and daddy. You realize that since 1880, when numbers were first kept, there's been a steady progression. More and more young people want to start on their own and a family and a house away from mom and dad. However, now we're seeing a reversal of the trend. In fact, the highest level of failure to launch is taking place between the ages of 18 and 34. Fully one-third of them live with mom and dad. The reason? Well, many social reasons, of course, but of course the primary reason is the economy. There's simply not enough good-paying jobs out there so that young people can start up on their own, start to have kids, and make a family. Also, the cover of the New Yorker, I think, is quite interesting. The month of May and June, of course, is the month of commencement. And it's a time when commencement speakers talk about the new vistas and challenges of tomorrow. But if you look at the cover of the New Yorker, it shows the class of 2016 throwing their hats in the air. But then there's a gardener that's pulling the cap and gowns from the top of the trees. The gardener has a sign that says, Class of 2015. In other words, the class of 2016 can look forward to downsizing in terms of their jobs. And then the question is, what's really at fault? What is causing this schism within the American population? Also, Mars is in the news. First of all, if you're an amateur astronomer, you have to realize that Mars is the closest in 11 years. And you may have to wait another decade to have the planet Mars as close. And so if you have a telescope, you may be tempted to go out on a starry night and look at the red planet. And we'll say a few things about what you may see if you look in the direction of the planet Mars. However, going to Mars has also gotten a boost because the people with Stephen Hawking, who proposed a new version of a starship, have also said that their starship can easily go to Mars, cutting the time to go to Mars perhaps by a factor of 10 or so. And so we'll talk about a new way to go to the planet Mars. And on the downside, even though the administration says that we're going to send humans to Mars around 2030 or so, there's yet another problem. In addition to weightlessness, in addition to micrometeorites and accidents, we have the danger of gigantic mega solar flares, tsunamis from the sun. A new report shows that there has been a new evidence of a gigantic solar flare that hit the Earth in the year 775. 1,000 years ago, that was the mother of all solar flares that hit the Earth. And if that solar flare were to hit the Earth again, well, astronauts would be fried as a consequence. And then we'll say a few things about the Neanderthals. First of all, there's been a revolution in anthropology and archaeology because of the fact that we can now extract DNA from the plaque of ancient teeth, and as a consequence, reconstruct the entire genome of that fossilized individual. This is revolutionizing the way we view ancient civilization. And then the question is, well, what killed off the Neanderthals? Did we do it? There's a new theory coming out which is rather interesting about what may have done in the Neanderthals. And then we're going to bring on our special guest today, Dr. Seth Shostak, a friend of mine. He's the director of the SETI project, the Search for Extraterrestrial Intelligence. Yes, he is a real physicist, a PhD physicist. And what does he do for a living? He looks for evidence of little green men in outer space. He has gigantic radio telescopes by which he hopes to pick up messages from ancient or perhaps futuristic civilizations in outer space. So we'll say a few things about the SETI project in the second half of Exploration. Well, let's just jump right into some of the top stories of the past week. As everybody knows, it's going to be Hillary Clinton versus Donald Trump, at least until the conventions occur later this year when it's finalized. But it does seem as if those two are squaring off because of the enormous implications. And all the polls seem to indicate that it is the economy, not terrorism or immigration, but the economy that seems to be the number one issue currently on people's minds. And we have two reports. One from the Pew Center, an organization that canvasses the demographics of a changing American landscape. And they have analyzed numbers going back to 1880. Now, if you think about it, back in 1880, America was largely an agrarian society, but even then with the coming of the Industrial Revolution, there was more money to be had. And if you were a young kid, what you wanted to do is set out on your own. That is, make your fortune, start a family, have kids, and start all over again. That's been the way it's always been in this country since 1880, except now. Now, fully one-third of young people, young adults from 18 to 34, live with their parents. And of course, there are advantages to living with your parents. You don't have to pay for rent, you don't have to pay for food, and perhaps you don't even have to pay for laundry. But of course, your parents want to retire, and at a certain point, they want to kick you out of the house as soon as you get your job. And that's the rub. The class of 2016 has a very dismal prospects for getting a job. And that's the cover of the latest New Yorker magazine, where we have all the bright-eyed, bushy-tailed graduates of 2016 throwing their cap into the heavens. And then right next to them is the gardener, a gardener with a sign on his back that says Class of 2015. And his job is to catch and knock down all the caps that are in the treetops. So, in other words, what do the people of the class of 2016 have to look forward to? Chances are it's unemployment. Now, some people may rail against the top 1%, and yes, the top 1% have done very well in the last few decades. But if you look at the numbers more carefully, you realize that it's just not the top 1%. It's actually the top 1/3 or so, depending upon which numbers you look at. But about the top 1/3 have done very well. It's the bottom 2/3 that's the problem. The bottom 2/3 have either stagnated, held their own, or gradually gone down in terms of their share of the national income. And so we're seeing a bifurcation and the flattening of the middle class in this country. And then the question is, why? Of course, that's the number one question. You know, the New York Times last year had a 2-page article, 2 gigantic pages of the New York Times devoted to the flattening of the middle class and the rise of the 1%. And they had story after story of people who lost their job, people that are no longer part of the workforce, and yet they didn't answer the question, why? In fact, after reading this huge article, I saw one paragraph, one tiny paragraph that said, oh, by the way, the reason for this has something to do with technology. And then off it went, talking about the next person who just got laid off. Well, let's talk about technology. We have automation, we have computerization, we have globalization, all of which stem from the computer revolution and the revolution in science, and they are changing the workforce. Now, what's the solution of the politicians? The solution of the politicians is, well, taxation. You see, politicians are former lawyers. And in law, everything is a zero-sum game. You sue Peter to pay Paul. Paul loses, Peter wins. It's a net zero for society. So that's called the law, suing Peter to pay Paul. And then when a lawyer becomes a politician, it's you tax Peter to pay Paul. Now, in my point of view, taxing Peter to pay Paul, well, yeah, it does do some things, but it's like rearranging the chairs on the Titanic. Wouldn't it be better to simply repair the Titanic and energize it and get it back up to speed again, rather than simply rearranging the chairs on the Titanic? You see, if the problem is technology, then why not confront it directly, rather than writing article after article after article in the New York Times about the plight of working people that can no longer get a job? You see, if the solution is just taxation, then, okay, you simply rearrange the money, but you're not generating new wealth. So where does wealth come from? Let's look at history. History shows that there have been 3 waves of wealth generation. Throughout human history, for thousands of years, we lived either as hunter-gatherers or in the last 10,000 years as farmers and peasants, tilling the soil. It was back-breaking work. The average lifespan of a typical individual was in the range of 30. And so that's the way it was for thousands of years until the first wave hit, and that is the steam revolution. The coming of the Industrial Revolution, energized by steam power, created a tremendous amount of wealth. In fact, there was so much wealth generated that it created a bubble the likes of which had never been seen before on the London Stock Exchange in railroad stock. So many people were investing in the railroads because that was the obvious manifestation of the steam revolution. Well, the bubble was unsustainable and it popped in 1850, creating the first great crisis of capitalism, the first of many. In fact, the crisis was so severe that it even created a backlash, a new philosophy, a philosophy called Marxism. Well, 80 years later, we scientists left the steam engine and we went on to initiate the electric revolution. And all of a sudden we had television, radios. All of a sudden we had electrical appliances in the household, labor-saving devices. And that generated the next wave of wealth, even bigger than the first wave, but it created a bubble. This time the wealth created a bubble on the American Stock Exchange in utility stock and automobile stock, because that's where a lot of the technology went, into the cars and into electric appliances. Well, that was also unsustainable, and the bubble popped in 1929, creating the Great Depression. And now we have the third wave of wealth generation. High technology, lasers, computers, the internet, the space program, iPhones, you name it, it all comes right out of modern electronics and the space program. And that created an even bigger wave of wealth, the third wave of wealth. And where did that money go? Into American real estate. And when it popped recently, it practically sank the entire world economy. So now we're about to hit the fourth wave of innovation and wealth. The fourth wave, we think, will be artificial intelligence, biotech, nanotech. In other words, science at the molecular level. That's going to be the fourth wave of wealth generation. So obviously, what should we do? We should try to cultivate that wave. We should educate people so that their skills are adequate so they can perform when the fourth wave really hits. We should also encourage entrepreneurs to start new companies based on biotech, nanotech, and AI. We should reduce taxes and encourage them, give them tax breaks to start new companies. And the government can sponsor some of the research necessary, because, of course, in the past, government-sponsored research programs gave us, for example, the space program, nuclear energy. And so the government can also do something. But simply taxes, well, yeah, taxes rearrange wealth, but it doesn't create wealth. And that's what we're really talking about. Also, Mars is in the news. If you are an amateur astronomer, you may want to take out your telescope and point it along the ecliptic, which is a long line that extends east-west if you faced in the southerly direction. And Mars is right there. It's quite noticeable because it's red. Red because of rust. Mars is the rusty planet. Ferric oxide, rust, is the reason why Mars is red, not because of blood, which is what the Greeks and the Romans thought. And if you look at Mars and your telescope is powerful enough, you may make out the ice caps. The ice caps that are white at the North Pole and the South Pole. The ice caps are mainly made out of carbon dioxide frozen, dry ice, and also ordinary water ice. And if you're lucky, you may see a flash of pink light called Hellas. Hellas is a gigantic meteor impact crater in the northern hemisphere of Mars. So if the light is just right, you might be able to pick up a flash of pink light, which is the reflection of Hellas, a gigantic meteor impact crater on Mars. And speaking about Mars, we have perhaps a new way of getting to Mars. Stephen Hawking just last month debuted a new way to build a starship. A starship not the size of the Enterprise from Star Trek, but the size of a postage stamp. A chip that you put on a parachute, and then you inflate the parachute by shooting high-powered laser beams and then pushing the parachute to 20% the speed of light. It's a great idea, but of course it'll take a whopping laser beam to do that. But why not aim that laser beam to Mars? Then we can reach Mars perhaps not in a matter of a 2-year voyage to Mars, but perhaps a voyage that only lasts a few days. Think of it, cutting the time to go to Mars. For example, to go to the moon, if you were to jump from the Earth to the moon, it would take about a second to do that. Now, remember that these postage stamp parachutes go at a fifth the speed of light, so in 5 seconds, you could conceivably go to Mars. Now, if you send a radio signal to Mars, it takes 20 minutes depending upon where Mars is. But if you're going, 1/5 the speed of light, you're talking about reaching Mars in less than a day. And so people are now doing the math, the engineering, to calculate what would it take to have a laser beam carry our astronauts to the planet Mars. And speaking about going to Mars, solar flares are yet another danger for our astronauts. It was recently revealed that by analyzing tree rings of trees that recorded history going back thousands of years, we find evidence that in the year 775, there was a humongous solar flare erupting from the sun. If that solar flare had hit the Earth today in the electronic age, it would have wiped out telecommunication and caused trillions of dollars in property damage. The closest thing we have to this is the Carrington event of 1859. In 1859, the astronomer Carrington saw a gigantic flare on the surface of the sun, and yes, just a day later, there was havoc with all electronics around the Earth. Telegraph wires, because that's all we really had back then, telegraph wires would spontaneously create combustion, sparks, and even fires on the telegraph paper. It turns out that the northern lights, which is usually seen near the North Pole, could be seen all the way down to Cuba. And you could read the newspaper at night by the light of the northern lights in Cuba because of the enormous radiation from the Carrington event. Well, we now know that the incident of 775 and 1859 were catastrophic if they had hit the Earth during the electronic age. First, you would knock out our satellites. Telecommunications would go down, the internet would go down, astronauts would be in danger because they are in outer space. So first, telecommunications are wiped out because satellites go out, weather satellites, telecommunications satellites, all of it going out as a consequence. Then power stations on the Earth would be short-circuited, and so that means that lights will go out. That means that people's refrigerators can no longer cool down food. So within a matter of days, you're talking about food riots taking place. And remember the blackout that we had in the Northeast about 10 years ago? I remember that blackout very well. I was filming in Coney Island, actually, with BBC Television for a special I was doing for BBC Television. And I remember that in Times Square shut down because of the fact they couldn't do credit card transactions. You go to a hotel in the Times Square area, you couldn't find a hotel room because all the credit card machines were out. And that would last for days, weeks, maybe months, because the entire planet would have a blackout. When there's a small blackout on the Earth, it means that we have backups. It means repair crews come out and fix the problem. But if the entire Earth is blanketed by a mega tsunami from outer space, it means that even the rescue crews would also be affected. Now, you may say to yourself, how often do these catastrophic events take place? Now, how much damage would occur? The damage would be about $2 trillion. We physicists went to the United States Congress, told Congress about the threat of a mega tsunami from space, and all we got was the giggle factor. The politicians simply giggled and gave us nothing. All we asked for was a few $100 million to reinforce power stations, build redundant systems, reinforce what we have, and have backup systems. But, hey, they just laughed at us. So, in other words, we are a sitting duck to perhaps yet another Carrington event. Now, how often do they take place? We don't know. However, in 2003, we had a near miss. A solar flare just missed the planet Earth. If it had hit, it would have been another Carrington event. So we now realize that these Carrington events are much more frequent than we previously thought. Most of them miss the Earth. Sunspots on the sun are like rifles. Think of the sun, think of sunspots, and think of each sunspot as a rifle shooting out bursts of solar plasma into outer space. For the most part, these bullets miss the Earth because, of course, space is pretty big and empty. But once in a while, these bullets will hit the Earth, causing the catastrophe of 1859 and 775. So, in other words, these things can happen perhaps once every few centuries. So, in other words, we may be overdue for another Carrington event. Also, speaking about the past, Neanderthals are in the news. It turns out that the latest DNA techniques allow us to extract usable DNA from the plaque on the teeth of these ancient fossils, allowing us to reconstruct the entire genome, and therefore nailing to the wall many conjectures about Neanderthal. We now realize that, yes, we have Neanderthal DNA in our own DNA. In fact, I interviewed one of the scientists who did this study, and he mentioned that perhaps red hair is comes from a gene that we inherited from the Neanderthals. Of course, that's still debatable, he said, but there are indications that, yes, there are characteristics that we inherited from the Neanderthals. Not only that, but we also realize, much to our shock, that there's another branch of humanity that coexisted with the Neanderthals and Homo sapiens tens of thousands of years ago during the Ice Age, and these are the Denisovans. The Denisovans are a species of humans that lived in Siberia. We have no known skeletons of them. We don't know what they look like. All we have are these fragments of fossils and enough DNA from the teeth to reconstruct their genome. So we now realize that Homo sapiens, that is you and me, Homo sapiens coexisted with other species of humanity during the Ice Age, perhaps about 40,000 years ago. You know, when you see the movie The Lord of the Rings, it's quite surprising because you see different branches of humanity coexisting with each other. You have, of course, the humans, and then you have the dwarfs, and then you have other sub-branches of humanity. That may actually have been closer to the reality 40,000 years ago during the last Ice Age. Also, what scientists have found is that by analyzing the bone fragments left over from a meal eaten by the Neanderthals, we have evidence that it was global warming. In fact, global cooling in this case, that perhaps done in the Neanderthals. Some people think that perhaps humans killed off the Neanderthals. Other people think, no, we just outcompeted them. outcompeted them for food, and that's what done in the Neanderthals. Other people think, well, maybe it was disease. Maybe they weren't as resistant as us to certain forms of disease. The new theory, which is gaining some credibility, is that it was climate change. Climate change that basically wiped out the Neanderthals. What scientists did was they painfully reconstructed the meals of the Neanderthals looking at the bone. Now, when you eat the bone, you want to actually get into the bone marrow. It turns out that at the height of the Ice Age, roughly 40,000 years ago, when it got really cold, it turns out the Neanderthals were scavenging deeper and deeper into the bone marrow, eating fewer and fewer meals. And so there is a theory, though we cannot verify it, which says that perhaps what done in the Neanderthals is climate change. It got cold, really cold, about 40,000 years ago. And as a consequence, food supplies began to dwindle, and it meant that it was much more difficult to hunt, and we humans had an advantage. We have a slimmer body, we're much more mobile, and perhaps we use some of our intellect to create clothing by which we could fend off the cold during the Ice Age. Of course, no one was there. We have all these theories, and yet we have yet another theory, that perhaps it was climate change that did in the Neanderthals. Also, we're going to bring on our special guest in the second half of Exploration, Dr. Shostak, who will talk to us about searching for alien civilizations in outer space. If there are alien civilizations out there, perhaps they have radio, television, in which case they are broadcasting just like we broadcast in outer space. And if so, it should be possible to detect their signals by creating radio telescopes powerful enough to eavesdrop on their conversations. So far, with any degree of accuracy, we've scanned about 1,000 stars. What do we find so far? Nothing. Zero. But now with the Kepler satellite, we are identifying the stars that have planets going around them that may even be Earth-like. And that, of course, is allowing the SETI people to zero in on the most likely candidates for extraterrestrial civilizations. And so once again, in the second half of Exploration, we're going to talk about alien civilizations in outer space. Welcome. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is the second half of Exploration. You know, one of the big stories in science over the past few years has been the success of the Kepler satellite in terms of identifying planets going around other star systems. This is a dream of astronomers and scientists. I remember that when I was a kid in elementary school, we learned that there were 9 planets that went around the sun, and we thought that perhaps our solar system was average, that perhaps there are lots of solar systems out there in outer space that look very similar to ours, and that was sort of the prevailing thought, though of course the very idea that we could send probes and identify these planets was far beyond anything available to the scientific community. Well, boy, were we wrong. We now realize that other solar systems out there, thousands of them, perhaps none of them, almost none of them look exactly like ours. But it does raise the question, since there are so many planets out there identified by the Kepler, many of them Earth-like, then the question is, well, what are the odds that some of them have intelligent life on them? Well, you can calculate the odds. The odds are about 1 billion. About 1 billion stars in our own backyard, the Milky Way galaxy, according to the census taken by the Kepler satellite, have planets that are Earth-like. That is, they are just right from the sun to have liquid water. Not too close where the oceans will boil, not too far when the oceans will freeze, but just right from the sun to have liquid water oceans. And liquid water is, quote, the universal solvent. Except for some minerals and oils, water dissolves a lot of substances, and that's basically the amniotic fluid out of which the first proteins and DNA got off the ground, and that then makes the process of creating life in outer space. Well, to be fair, we've looked in outer space with the SETI project, the search for extraterrestrial intelligence, but so far we find nothing. Nada. Zero. Zip. Nothing from outer space indicating that there could be intelligent life. But that doesn't stop Dr. Seth Shostak, one of the directors of the SETI project. He has a PhD in physics. Instead of lecturing at some prestigious university, he spends his time looking at data from radio telescopes, searching for signals that indicate there is an intelligent civilization out there. So the first question we're going to ask Dr. Shostak is, well, how do you know that radio is the way to listen in on these alien civilizations in outer space? Maybe they use some other means, but what are your thoughts?
Well, that's actually a good point because, of course, you know, the aliens haven't sent us a fax telling us where on the dial they might be broadcasting. So you have to sort of second guess what frequencies, what part of the dial makes sense. And that idea had already been explored, even though Frank Drake didn't know that, by a couple of guys who at that point were at Cornell University, a couple of physicists by the name of Giuseppe Cocconi, and Philip Morrison. Anyhow, these two guys had already thought about what frequencies make sense if you're going to send messages between the stars. And they said, well, look, there's kind of a natural answer to that because there's one frequency everybody will know, and it turns out to be 1420 megahertz on the dial. You might think, well, what's special about that? It turns out that hydrogen, which is by far the overwhelmingly most common element in the universe, hydrogen naturally emits some radio emission at 1420 megahertz. So all astronomers, you know, of any sophistication in the universe will know about this frequency. So they said, look, that's a natural frequency. Everybody will have it marked on their radio dial. Let's try listening there. Frank Drake came to the same conclusion rather independently. And so the first experiments were done usually with a receiver that only had one channel. It could only listen to one channel at a time, just like your auto radio, and set that frequency somewhere near this 1420 megahertz magic frequency of the dial. Now, as time went on, this kind of experiment became much more sophisticated. Today, the receivers that are used for SETI listen simultaneously to tens of millions of channels at once because, you know, you don't know exactly which frequency might be the one they're using, but they tend to look at that part of the dial around 1420 megahertz. Not always. Sometimes they'll do experiments where they're looking elsewhere, but usually you're covering maybe 1,000 or 2,000 megahertz around that frequency. So, you know, it's a small fraction of the dial, but it seems to be a pretty good one. No one's ever come up with a better argument about where to tune.
Okay, now let's talk about Drake's equation, which is taught in every elementary astronomy course as scientists try to get a reasonable scientific estimate of the probability of intelligent races throughout the galaxy. So tell us a little about Drake's equation.
Well, the equation actually has an interesting history, or at least semi-interesting. Frank Drake had done that first listening experiment in the spring of 1960. So, gosh, that's 45 years ago. It was in April, I think, 1960. Anyhow, so that generated a lot of interest. I mean, he didn't find aliens, but it generated a heck of a lot of interest. And so the next year, he had a meeting, also in West Virginia, at the observatory, in which he invited all the kind of professional scientists who were interested in this work. That total was like 10 or 12 or something. It was a fairly small number. And as an agenda, he was sitting around thinking, well, this meeting's coming up in a couple of weeks. I need an agenda. So as an agenda for this meeting, he wrote down this very simple equation, which has subsequently become known as the Drake equation. And all it does is try to estimate something called N, where N is the number of civilizations in our galaxy. Just let's confine ourselves to our galaxy that are broadcasting right now. So the number of star systems, if you will, that are producing signals now that we could detect. Now, clearly, that depends on, well, how many stars are there in the galaxy, and what fraction of those have planets, and what fraction of those planets have produced life, and what fraction of those that have produced life have produced intelligent life, and what fraction of those have produced technology, and what fraction of those. those are actually on the air right now. Okay, so it's a whole string of terms. There are actually 7 terms in the equation. You can find it in almost any textbook on astronomy, and that's the Drake equation. And it would be great because it would tell you, what are your chances of success? I mean, if N is only a few, then the chances that you'll find these guys is pretty small. But if N are thousands or millions or some very large number, Carl Sagan thought that the value of N was several million. Well, if that's true, then, you have a pretty good chance of tripping across a signal sooner or later. So, unfortunately, of course, we don't know what N is. There are a bunch of terms in the equation that we simply don't know. So it's more of a talking point kind of thing than it is an equation that you can actually solve or use.
And that completes the first part of our interview with Dr. Seth Shostak. He's the director of the SETI Institute in Mountain View, California. That's the Search for Extraterrestrial Intelligence. And their webpage, by the way, is www.seti.org, SETI.org. And the other day, both Dr. Shostak and I appeared on that ABC special on UFOs. And I think it's both fair to say that Dr. Shostak and I take the opinion that the vast distances separating the stars are so huge that it would take a very advanced civilization to breach those distances. So, in other words, any visitation, hypothetical or real, from an extraterrestrial civilization would reflect the fact that they are advanced, perhaps hundreds of thousands, perhaps millions of years more advanced than ours, and they would be utilizing a technology that we can only dream about on the planet Earth. Well, let's now get back with a discussion about other worlds in outer space. Just before the break, we were talking about calculating the probability of finding intelligent beings in outer space. However, there are some people who simply don't believe in the probability equations that we laid out. Other scientists say, bah, humbug. We had Professor Brownlee on our airwaves about a year and a half ago, and he said that Drake's equation is flawed. Flawed because there are new astronomical bits of information that show that, to get life is more difficult than we thought. He mentions, for example, that you need a large moon. Without a large moon, the Earth would eventually tumble in its orbit and over hundreds of millions of years, and that would make DNA impossible. He also mentioned the fact that at one point the entire Earth was frozen over. We were snowball Earth. And again, DNA would be very hard to get off the ground under those circumstances. He mentions you have to have a large Jupiter in order to clean out the debris of the solar system. He also mentions you have to be a certain distance from the center of the black hole at the center of the galaxy. Otherwise, you get fried by being too close to this very radioactive core at the center of the galaxy. But if you're too far out, then there are not enough heavy elements to create DNA and higher molecules. So, what are your thoughts? Is the Earth in some sense unique, as Professor Brownlee was hinting at? Or do you think N is quite large, as Carl Sagan believed?
Well, of course, nobody knows, so everything I'm going to tell you is my opinion on this.
Okay,
obviously.
Good enough.
If we knew the answer, we wouldn't be discussing it, but it's true. Don Brownlee and his colleague Peter Ward at the University of Washington up in Seattle wrote this book about 5 years ago called Rare Earth, in which they had indeed, as you indicated, kind of a laundry list of, reasons why Earth might not be just a run-of-the-mill planet. Earth might be very, very special, so special that, in fact, although there might be some other life out there, it's not going to be very sophisticated life. It isn't going to be intelligent life. And so our SETI experiments are kind of a waste of time. That was their thesis. And since this was reviewed, by the way, in the New York Times, this book got a lot of play. And but if you actually look at this laundry list, you find that the items on it are not terribly convincing. Let's take a couple of the ones you named, for example. The fact that the Earth has a large moon, which kind of stabilizes the spin of the Earth. Okay. Now, if we didn't have that large moon, and by the way, a large moon is kind of a rare thing. Mercury doesn't have a large moon, has no moons. Venus doesn't have a large moon, has no moons. Mars has a couple of moons. You could walk around in an afternoon. Tiny moons, they don't help. Earth, on the other hand, among the rocky planets, is the only one to have a large moon. Okay. And sure, it does stabilize the Earth's spin. But if you took that moon away, yes, well, the Earth wouldn't, just go completely nuts. Every now and again, the North Pole would come down to, Connecticut or some other place, that sort of thing. But it would take hundreds of thousands, maybe millions of years to do that, right? So it's such a slow event that even for complicated life like freshwater otters or whatever, right, they can just walk away from that problem. If you've got 100,000 years, before the North Pole gets to you, you have plenty of time to move. I mean, that isn't fatal to life. That's not fatal. It might be an inconvenience, if you had a society with a lot of cities, you might not want it to happen. But it's so slow. It's not fatal. Now, here's another thing in your list there. You mentioned we're fortunate to have Jupiter because Jupiter has cleaned out the inner solar system of all these big rocks that otherwise might, slam into your planet and ruin the whole day, just the way it happened 65 million years ago, taking out the dinosaurs and 75% of all other species. Well, sure. But on the other hand, big Jupiters are not rare. We know that. In fact, all the planets we've found around other stars are like Jupiter are bigger. So big planets are not rare. But even aside from that, you could argue that maybe life on Earth would have gotten a little bit farther had we not had such a big planet as Jupiter out there. Because, in fact, if the dinos had been wiped out 50 million years earlier, we would be 50 million years ahead of where we are today. We'd have the cure for death, whatever. It would be, maybe we'd be better off. So I don't find that a very convincing argument. I mean, you can look at each one of these arguments. The snowball Earth, yes, there's some evidence, although it's somewhat controversial, but there's some evidence that there was a time, a few billion years ago, when the entire Earth was encrusted with ice. But there was life on Earth then. And that life wasn't wiped out by snowball Earth. It just, had to sit there and, live at the bottom of the oceans for a while. But, a lot of life, all life was down in the oceans anyhow. So, it didn't wipe out Earth. It wasn't fatal. Okay, so all these things, yes, they might be an inconvenience, or they might not be, but in any case, none of them stopped life on Earth. None of them stopped life on Earth. So I really don't think that Earth is really all that special.
Well, Professor Brownlee goes on, in fact, on and on and on, as I found out interviewing him. He also says that microbial life could, in fact, be quite common throughout the universe, but intelligent life, well, take a look at the dinosaurs, he says. We've had life forms with spinal cords and nervous systems for hundreds of millions of years on the Earth, but humans, only humans on the Earth, even on the Earth with such ideal conditions, it took hundreds of millions of years for humans to get off the ground. And even then, there were many times when humanity may have been wiped out. There were only a few thousand of us, 100,000 years ago to create the entire human race. The human race could have been wiped out many times during certain bottlenecks in our evolution. So he was basically saying that intelligent life is extremely rare, even if you have microbial life being common. What are your thoughts?
Well, he's right in that this is a controversial area. I think even more controversial than the question of whether you can get complex life on a lot of planets. I don't think that's so controversial myself. But just because I give you 1 million planets with life, right, and you let them cook for a few billion years, there is a legitimate question. What fraction of them will ever cook up something as clever as, as we are? and we are clever compared to most critters around, right?
That's debatable, but anyway.
Well, but in any case, I mean, we don't know because we still don't understand fully how, or even partially really, how intelligence evolved on Earth. What was it that produced intelligence on Earth? If it's a mechanism that was just very rare in the sense of being accidental or contingent upon a lot of special circumstances, then maybe he's right. Maybe you got lots and lots of life out there. Maybe Captain Kirk takes the Starship Enterprise out into space and finds lots and lots of life in the galaxy, but it's all stupid. Okay, that's one possibility. But on the other hand, all the studies that have been done about how intelligence arose on Earth suggest that, well, what drove it was nothing that you wouldn't expect elsewhere. And sure, it took a long time before you got this far, but you needed some preconditions. You needed warm-blooded animals with a high metabolic rate. You needed all sorts of sort of biological developments. And then, in the last 50 million years, which of course is fairly short in the history of the planet, but in the last 50 million years, a lot of species have gotten smarter. It's obviously Homo sapiens, but, and obviously our simian relatives, right? Chimps are pretty clever. But, birds are pretty clever. Even octopi are fairly clever. Whales and dolphins are fairly clever. There's been an increase in intelligence among, a couple of handfuls of species in the past 50 million years. It isn't just one species that got smarter. Now, we got smarter than they did, but if you were to visit Earth 2 million years ago, you would have found that the smartest things on the planet were not our simian ancestors, but some white-flanked dolphins. They had the highest IQs, and they didn't leave a lot of literature, but they were the smartest things around.
Mm-hmm.
So it does seem that intelligence is actually kind of a fairly natural product of evolution once you get to a certain level of complexity. This is controversial, but at least the indications are that intelligence is not some sort of miracle.
Okay, well, shifting gears a little bit, we also had Professor Dan Wertheimer from the University of California at Berkeley on our airwaves a few years ago, talking about SETI at home. That is, on your home PC, you can get a chunk of this radio data and have your PC via its screensaver basically crunch some of the numbers to look for intelligent signals. What's been the progress for SETI at home in the last several years?
Well, SETI at Home was intended originally just to be a very short-lived project, maybe for a year or two, but it was so popular that it's continued. They expected, maybe 50,000 people, would download this free bit of software so that when they walk away from their computer, it's still humming away, that it would process a certain amount of SETI data that it would download from the servers at the University of California at Berkeley. Well, more than 5 million people have downloaded that software,
Mm-hmm.
So that's, that's 100 times as many as they expected, and about a third of them use it at any given time. What they do is they distribute a little bit of the data they collect from the radio telescope down in Puerto Rico, the Arecibo radio telescope, which a lot of listeners may have seen in the movie Contact, movie GoldenEye. It's a great movie star. Yeah, they distribute about 1 or 2% of the data they collect there on the web for people using the screensaver. But the point is that there are so many people doing this with their home computers that it is by far the largest computer project, the largest computer, if you will, in the world right now. And those data are looked at extraordinarily carefully. So, it's really a very, very fine-tooth comb. They look at all the rest of their data right there at Berkeley using, the local Berkeley computers, but they can't look as carefully as they can at this small fraction of the data, which, are the prime data, if you will. Now, has anybody found something? Well, people find stuff all the time, of course. If you do these sorts of work, this sort of work, and you're using a big antenna like the one in Puerto Rico, you find signals all the time. That's right. You got this huge antenna. It's connected to a receiver that has millions of channels. Of course, you pick up signals. But of course, the question is that ET on the line, or is that AT&T on the line? Is it just interference from a telecommunications satellite or something like that? Now, what the guys at Berkeley do is they look at all the signals that have been found by people using their computers at home. And they look for those cases where a signal has been found more than once, in fact, more than twice. If a signal has been found 3 different times, right, not just by 3 different people, that doesn't count, but by, at 3 different times. In other words, the telescope was pointing at some spot on the sky and they find a signal, and then, 3 months later comes back to that same point, and somebody else finds it again at that same frequency, at that same spot on the sky. If that happens 3 or more times, then they say, hey, look, that's, kind of interesting from a statistical point of view. That suggests it's not just a noise spike that, looks like a real signal. And then they will go down to the telescope and will deliberately look at that spot on the sky for a long period of time, for a few minutes, whatever it takes, until they can verify whether the signal is still there. They have done that on several occasions. So far, no dice. But, on the other hand, it is quite possible that somebody running SETI at home could, in fact, find the signal that would entitle them to pick up a prize in Stockholm and have dinner with a king.
And that, of course, would be perhaps one of the pivotal events in human evolution on the planet Earth.
I think so.
Well, let me ask you now the $64,000 question. What do you, as an individual, think N is, N being the number of intelligent planetary systems out there, and where are they?
Yes, well, of course, I don't know what N is either, but I tend to agree with Frank Drake, who still works here at the SETI Institute. His office is down the hall from mine. And Frank is now, I guess he'll be 75 in another month or so. But he's still as active as he ever was. And he's a pretty smart guy, one of the cleverest guys I've known. And if you ask Frank, look, this is your equation. What do you think N is? He'll say, well, I think it's probably around 10,000, which is kind of a conservative number compared to Carl Sagan, who thought it was a few million. I think Isaac Asimov thought it was 2/3 of a million. So Frank is saying about 10,000. Well, if it's anywhere between 1,000 and, well, some bigger number, if it's more than 1,000, then that means that the nearest aliens are within, on the order of 1,000 light years, okay, to us. Now, keep in mind that if you looked at the whole Milky Way galaxy, it's about 100,000 light years across. So this is, only like 1% of the way across the galaxy. 1,000 light years. That's far if you're trying to drive it in your Honda, but it isn't so far for a radio telescope. If that's the case, and it really is, it's up for grabs. Obviously, we don't know. But if that's the case, then our experiments should find a signal within the next 20 years, because within the next 20 years, we will have kind of searched stars out to that distance. So that's my bet. But on the other hand, we're not going to know the answer until we know the answer.
And what are your thoughts about, well, where are they? SETI so far has picked up nothing. Is that just a question of lack of sensitivity of the SETI antennas, lack of detectors, or is it because they're shy out there in outer space? Or maybe they don't exist? Or, well, what are your thoughts about why we haven't picked up any messages yet?
Yeah, well, this, I think that the answer is very simple. I think it's simply because we've not combed enough galactic real estate yet. But there are people who say, no, the fact that you haven't heard anything yet means something. It means that they're not out there, because any society that was more advanced than ours, and most of them are going to be more advanced than ours. I mean, if intelligence really does occur on planets in a fashion that's not extraordinarily rare, then most of the societies out there will be much older than ours, because, after all, we're the new kids on the block. The Earth has only been here for 4.5 billion years. The galaxy's been around for like 3 times that length of time. So most of the stars out there are older than the sun. So if they're really advanced, then they should have been able by now to maybe colonize big chunks of the galaxy. Who knows? They should have been able to spread around. They should have, remote transmitters. They should be very easy to find, right? And the fact that we haven't found them sounds like some sort of paradox. In fact, this little argument is often called the Fermi paradox, because Enrico Fermi, the physicist, the Italian-American physicist, was the first to point this out over a lunch at, I think it was Los Alamos in 1950. But in any case, that's his argument. I don't think I buy into that. I don't think it's a matter of them being shy, being coy. Maybe some of them are shy. Maybe most of them are shy. But if only one society has a powerful transmitter out there, then we have a chance of success. I think the reason we haven't found them yet is that we haven't looked very carefully. And all of that is going to change in the next few decades, mostly because of the march of technology.
Well, my personal point of view is that if there's an anthill in the country and you're walking down this country road and you bump into this anthill, do you go down to the ants and say, I bring you trinkets, I bring you beads, I bring you nuclear energy and DNA technology, or perhaps maybe you step on a few of them?
Yeah, probably. I get phone calls just about every other day from people who have their own explanation of why we haven't heard anything, and it's usually because the aliens are put off by our environmental degradation and our, threatening one another with war and all that sort of stuff. But indeed, I think that from their point of view, none of that matters terribly much, any more than whatever wars the ants are getting into concern me. They don't.
Mm-hmm. Now, another stream of thought says that we're looking in the wrong place. For example, take a look at email. Email is compressed. Email is broken up and goes through many cities and then recombined at the other end. So if an alien civilization had even a primitive email system, and we were eavesdropping on it, we wouldn't hear much at all. The signals would be compressed in a way that we don't understand. They'd be fragmented and redistributed and reassembled someplace else in a code we don't understand. So we could be listening in to messages that are teeming with intelligent things in it, but we are simply too primitive to understand it. What are your thoughts about that?
Well, I'm sure there's a lot of truth in that. I don't expect that we are going to understand any of the messages, even to the point of being able to sort of break them up into the bits that that make them up. And it's also true that, there are all sorts of methods for encoding information, for sending bits around that are fairly sophisticated that we use. For example, your cell phone tends to use what is called spread spectrum technology, where the signal is spread all over the dial instead of being concentrated in one spot. That's very hard to find with a radio receiver unless you know all the details of their communications schemes. So, yeah, there are lots and lots of ways they could make the signal hard to find, but in the end it comes down to this. If they have a transmitter on, that puts a certain amount of energy somewhere in the radio dial, somewhere in the radio spectrum. And we don't worry about how it's encoded or what the message is or anything like that. We don't worry about the message when we do our SETI experiments. We're just trying to determine, is a transmitter on? We're looking for narrowband components to the signal, it's called, little, lots of excess energy, if you will, at certain spots on the radio dial. If we find that, we, of course, don't know what they're saying, whether it's something profound or whether it's something trivial like used car ads. We don't care about any of that. We're simply looking for evidence that their transmitters are on, because, after all, that's the proof that we're after.
And in summary, we scientists have to admit the fact that with all the money being spent and all the effort, so far we have found nothing. No solid evidence that life exists in outer space or intelligent life by looking at all the stars in the heavens. However, the true believers believe that they will succeed and change human history. Well, I'm afraid that's it for exploration. Once again, this is Dr. Michio Kaku, Professor of Physics at the City College of New York. You've been listening to Dr. Seth Shostak, a PhD in physics, Director of the Search for Extraterrestrial Intelligence.